And we're recording. Hey, Virge.
Hi, Mark. Hi, everyone. Thanks for joining us. What episode are we on, Mark?
Looks like we're on episode 6, and we are doing a
Ooh.
differential equation. And we actually are going to have more than one differential equation. So, specifically, one where we do some implicit differentiation. And to be honest, Virge wrote this, so her asking is a little disingenuous.
Ha ha ha. Well, although I can barely remember what I'm doing from moment to moment. So,
It's an excellent point.
and we've talked about what we're going to be doing for the next couple of episodes. So, here we are, episode 6. Thanks for joining us. It's a standalone, so if you haven't watched anything else, that's totally fine. And then we plan on doing a tabular problem with context and then a separable differential equation, maybe with context, maybe without. Those are up in the air, and we will release those as soon as we get them written for you. Uh,
And episode 8, for sure, we'll have a BC lanyap. I'll think about the tabular, see if we can get one in there. We don't have one today, but this is still super relevant. 60% of that BC test is AB, so hang with us, our Calc BC friends.
yep.
All right, Virge, are you gonna take the
I'll
screen
I'll
away?
go ahead and take the screen if I can. You gotta
I
let
need
me.
to stop, yeah, and
Okay.
allow. You're
All
good.
right.
You should be good.
Um, we didn't say it, but hopefully you know already that you should get this problem from that QR code.
Oh, that's
And
an
also,
excellent point.
Mark probably has it in the description below on the YouTube video. So here you already have it. Um, and so this is very traditional free response question. It also, like Mark said, this stuff shows up all the time in the multiple choice. So consider the curve M defined by the equation xy squared plus 3x minus y squared equals 10. Show that dy dx is equal to this quotient. Well, we have the answer. We just got to make sure to show the steps to get there. So I really love these questions personally because I
I'm
know if I,
happy when I see show.
yeah,
Like,
like I know,
all right,
yeah.
I got a target. That's
So if I make a mistake, I don't just like erase a negative. I go back and I try and find out where that came from, right?
right.
Okay, so just kind of taking a preview here, I'm going to differentiate with respect to x. I see a product rule I'm going to have to do. And I'm going to have to also be really aware about chain rule with the y squared terms whenever you have a y squared or a natural log of y or something like that. All right, so here we go.
And that product rule is important. You said that really fast, but it's
Mm-hmm.
it's
This is
so easy. It's like it's not two x's, it's not an x and a sine x, and so a lot of kids will just take the derivative of both. But if you're taking two derivatives, something's going on. It's a chain rule or a product or a quotient, right?
yeah. So for this product rule, I always say first times the derivative of the second. So I've got x, my first, times the derivative of y squared with respect to x is going to be 2y dy dx. And then plus the second, which is my y squared, times the derivative of the first. Well, the derivative of x with respect to x is just going to be 1. You can think of it as dx and then just simplify it, or you can just write 1.
The x changes with respect to itself at a very one-to-one ratio.
Yes.
Yes.
Derivative of 3x with respect to x is just 3. Derivative of negative y squared with respect to x is negative 2y dy dx, very similar to what I had done within that product rule. And then equals the derivative of 10 is 0.
And don't relax, right? When you get across that equal sign, it's so easy. I see so many students put equals 10.
Yes, agree.
Stay focused. The derivative of a constant, it is not changing.
Right. And from here now we do algebra. So I'm going to go ahead and probably subtract y squared from both sides and subtract 3 from both sides. So I have negative y squared minus 3 equals, let's see,
And
2xy.
alphabetize, yeah.
Yeah, 2xy dy dx, and then minus 2y dy dx. My objective here is to factor out that dy dx, greatest
Yeah.
common factor. And I'm left with 2xy minus 2y. At this point, I usually glance at my target. I,
Right.
I do not glance at my target the whole time, but I will glance right now and I will decide whether or not I'm on the right track. And I'm feeling good. I'm a little worried about these negatives, or I could see a student being worried for me about these negatives. But
I'm actually glad you did it this way because on your original work that you sent me, you did it so that the signs weren't an issue, and I had done it this way. So
um, yes, and that I did intentionally did it this way for the video because I think a lot of students are going to do it this way. We're going to take the derivative and we're going to move our terms that don't
keep
have a
that
dy
dy
dx.
dx on the left because that's
Mm,
the thing you want. Yeah.
right. But essentially, these two are the same. And in my opinion, on the AP exam, you would be good. I don't think you have
Oh
to
yeah,
reshow.
I agree. I agree with you.
Yeah, you're good because these are equivalent. If you want to restate that this is indeed the same as 3 plus y squared over 2y minus 2xy, you can, but you don't have to.
And
Um,
even if you did like a multiplication of -1 over -1 and ended up with minus 2xy plus 2y on the denominator,
mhm,
I don't think you would have to reorder. I do because you don't have to write the plus sign, right? It's more elegant. But
mhm.
yeah, I think any of those three would be fine that you have shown you could find dy dx.
Yes, I agree. Okay. The next thing we need to do, and I like to slice and dice my FRQ prompts. The next thing we have to do is we're told that there's a point P on the curve M near 2 comma negative 2 with x coordinate 1.8. Use the line tangent to the curve at that point. So we're going to have to write an equation of a tangent line to approximate the y coordinate of point P. So to write the equation of a tangent line, we need two things. What are they, Mark?
A point and a slope.
And we have the point. So if I'm thinking about my y minus y1 equals m times x minus x1, I can substitute in already my point. My y1 is negative 2, so y minus negative 2 is y plus 2. And then I've got my x minus x1. Okay, but how am I going to find my slope?
Only you had a rate of change
If
somewhere on the page.
only had a recipe for my slope, right? dy dx is going to be my slope. So dy dx evaluated at this point to negative 2, notation that your teacher may or may not use, but I think it's a great notation in this context here. So I'm just going to substitute in. This is a no calculator question, by the way. I don't know that we talked about that. Oh, we did. It's right up here. We just dove right in. So 3 plus negative 2 squared. In the numerator, I'm just substituting in right here. And then in the denominator, 2 times negative 2 minus 2. And then x is positive 2, y is negative 2. And you do need to be fairly okay with some of these middle school skills. Negative 2 squared is 4. 3 plus 4 is 7. Denominator, I'm getting negative 4 and then plus 8 when I do that multiplying. Is that what you got,
That's
Mark?
good. Yeah.
Okay. So positive 7 fourths.
Yep.
Okay. Boop, 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 boop. Putting that in here for my
Okay.
slope. Okay. Whew. I still have more work to do on this part. I
You
have to
still
take,
haven't.
yeah, I have to take 1.8 and substitute it in for x because I'm going to go ahead and approximate the value at 1.8 on this relation using the tangent line. Okay, so I'm substituting 1.8 in for x, 1.8 in for x. My advice is do not distribute yet. Don't distribute at all, actually, in this case. 1.8 minus 2 is what I would do first. On these kind of problems, I'm going to get negative 0.2. And I'm going to multiply that by 7 fourths. I'm actually going to write that as a fraction before I do. So negative 0.2 can be written as negative 2 tenths, or negative 1/5 is the same. And then times my 7 fourths. And as soon as I kind of have that written down, I usually subtract my 2 from both sides or just, bring that over, add it to both sides, whatever needs to be done there. And technically, this is correct, isn't it,
Well,
Mark?
you could have stopped a lot earlier, right? If you are afraid of that, uh, as Virge said, a little demeaningly, the middle school arithmetic,
Yeah.
you could have subtracted the two. You could have left your slope
Oh,
as that
totally,
mass.
totally. Yeah.
And we see it. It's really kids that are really test savvy. I mean, I think I like that answer. Of course, I did all the way to the end when I did it because
hmm
I like to know if the answer makes sense or not. But
Hmm.
yeah, there's a lot of places you can stop as soon as it's numeric, right?
I think it was -2 and 7/20. Was that our final answer here?
Yeah, because that's -2 minus 7/20. Yeah, you're good.
Yep, that's what I got
And
earlier.
so, or -47/20. Like I said, there are a lot of equivalent ways to write it, and they would all be fine. Um, we're going to talk about something in part C, but I'd kind of like to mention it here for the teachers as well as the students. Be very careful you read the question because this one said use the line tangent to the curve. Some will say find the tangent line, and then we'll say use the tangent line. So what Virge wrote in the second line wasn't actually necessary for this problem. She could have jumped in at the third line. She
Hmm.
could have put her 7/4 in and her 1.8 in at the same time. I was just to the right of that. I was thinking
Okay.
where you would plug in the point, the slope, and the 1.8 all
Hmm.
at once because it just said use the line tangent. It's safer to write the tangent line. I highly advocate for the way Virge did it, writing that second line, because sometimes they'll say find the tangent line, and then you do need to have that written. But
Yeah.
just something you could do. And they could also ask, is that an underestimate or an overestimate? As a whole new part C, this is something maybe your teachers can do with you, where you'd actually have to find the second derivative, which is not trivial, and look at
Well,
whether it's
which is
concave
why
up
I
or
didn't
concave down.
ask it,
No,
given
and
what
I
the
know,
first
but
derivative looks like.
I think it's important to think about other things that could be asked, right?
Sure. Sure. Um, yeah, we
And when
weren't
they do that, the second derivative would be nicer. They would not ask it was something this tedious. So
right. Um, yeah. Okay, so that's my answer. Oh, what I was going to say about this is that if this were kind of a standalone multiple choice question, absolutely you would have to get it to this level.
oh, right. Yeah,
You
because then
know,
you'd
so
have to match up with the -47/20 that would be sitting there because they
it's
wouldn't have it as
never
a mixed number either.
yeah, it's never a bad idea to take it in your practice, even though it's an FRQ, to take it all the way to the end game or end result, even though even though on the actual test when you're don't want to make a careless mistake under pressure, you would leave it as
But
is.
definitely, you're right. Big picture, you want to consider what you might have to do in a multiple choice.
Yeah. Okay. So speaking of multiple things that could be asked here,
Mhm.
in part C it says determine if there are any points on the curve M at which the tangent to the curve at that point is vertical. Ugh, instead of vertical, what could you be asked?
You could be asked for horizontal.
Right. So that's a great thing to do with your study group or with your teacher, but we're going to focus on what you do with horizontal. I mean, with vertical,
With
my bad,
vertical.
with vertical. Find the coordinates of all such points. So when we see this, we want to find like an ordered pair or a couple of ordered pairs, okay? We don't want to just say x equals 7 or something. Find the coordinates of all such points, if any. There might not be any. Use your knowledge of English to help you answer these questions. If it said find the coordinates of all such points, period, you would know that like you're going to have at least one. Show the work that leads to your answer. Okay. So let's see what we need to do. If the tangent to the curve is vertical at that point, what do we need to do with our derivative, Mark?
We need some rise and some no run or some vertical change with no horizontal change. So we need 0 in the denominator
Mm-hmm.
and not 0 in the numerator. 0 in the numerator actually causes some problems.
Mm-hmm. So setting the denominator equal to 0, we can go ahead and, well, I went actually back to the original, but you could go back to whatever, but I would go back to the
Yeah.
original dy dx. Maybe take 2y out again, so 1 minus x, that would be, is equal to 0. Set each of these factors equal to 0, so 2y equals 0, y equals
He's
0.
saving that fancy X too.
Yeah, that was just a mistake.
Cool. No, that's cool.
Yeah. Okay, so we have y equals 0, x equals 1. So this is not the point 1 comma 0. Okay, something is happening when y equals 0.
That's a very important. I'm going to say that again for the people in the back.
Okay, okay. Unmute. And this is not going to be the point 0 comma 1. I mean, it might be,
Right.
but something is
Highly
happening
unlikely.
at y equals 0. And then something else is happening at x equals 1. We need to go back to our original equation and substitute in 0 for y and see what happens. then we might have an ordered pair, and then we need to do the same with x equals 1. So let's go ahead and do for, for the y. When I substitute in 0 for y, I get, let's see, x times 0 squared. I'm checking this one right now. Plus 3x minus 0 squared equals 10. So I'm getting 3x equals 10, or x equals 10 thirds when I divide. So it's
You
looking
have a
like
point.
one of my answers is 10 thirds comma 0. Okay. Then now I'm going to substitute in 1, same equation. So I'm going to have 1 times y squared plus 3 times 1 minus y squared equals 10. So I get y plus 3 minus, sorry, that's a y squared, plus 3 minus y squared equals 10. This is looking weird.
Yeah,
It's looking
something
like 3
weird's
equals
happening.
10,
So every time 3 equals 10, that coordinate works.
which means never.
Yeah. And since 3 doesn't ever equal
Mhm.
10,
But you have to check it. Like this is, you're justifying that you're rejecting x equals 1 as a possibility.
yeah.
So you don't have to write a treatise on that or anything like that.
No.
But I think this would say, maybe say no solution, or just even leave it as 3 never equals 10, and just like this is the only one that you're declaring. So
There
good,
needs to
Mark?
be evidence you considered y equals 0, right? Or the x equals 1, yeah.
Yes, I have to
Or
do
both.
something with
You have
this
to have
x.
evidence that you considered both of them, yeah.
Yep, yep.
All right. Is it
But
time for me
either
to take it
way,
away?
go ahead and take it away. I don't know if I need to stop my share. I always get confused by that.
I
Um,
think I should be able to take it.
okay. Um, by the way, these are great to look at on Desmos once you're done and just kind of see what the curve looks like. We're not going to do that, but that would be a fun thing to do, and just see if you saw a vertical tangent at 10 thirds comma 0, for example. Anyway, okay, Mark, your turn. Part D.
And go ahead and try and stop your share just in case there's any
I did.
overlap. And if
I
okay,
did, but
good.
I had to
All right.
like go to my other screen first, and yeah.
Okay. And here's, of course, my copy of the original problem, but we're gonna get on down to D. And I brought along the stem. I didn't cut and paste like Virge did, but I did say it's going to be useful to have this dy dx in all these parts. So I brought that part A along. It says a particle moves along the curve M, but the instant when the particle is at the point 2, -2, the x dt is -3/7. Find dy dt at that instant and show the work that leads to your answer. And I'm going to say right now, I'm going to do this one two different ways. And I'm saying that because no matter which one I do first, there's going to be somebody going, well, that's not how I would have done it. That's okay. And actually, there still may be a way. There's times we do that, right? But I just want you to know there's going to be two attacks on this one. Um, and I don't know, Virge, which I guess what occurs to you to do naturally, do you think?
To me, to do naturally is to just differentiate that original equation with respect to t.
Okay, so
And
so that'll be our method one.
okay. And that's what I
And
would do every single time, honestly, because um, it, I might
don't
not
give
be.
away method two yet.
Yeah, the issue is that we already have found a really interesting piece of the puzzle if we want to do method 2. If we
So
if we if
and
we don't want,
I asked you not to give it away.
okay, I'm stopping my
Stop
talking.
talking.
Stop.
Stop talking. Okay. And I think this is the way a lot of students would do it. I would prefer if my students did it by method two, but we'll get there. Um, the derivative of xy squared, but again, now we're doing this ddt, and I'm actually going to write that down just to keep it in my head. So neither of these is t, but I do the left one first. I do a left-hand product rule. Virge does right. So derivative of x is 1, but I'm not taking the derivative with respect to x anymore. So this dx dt shows up. And then I'm going to add my x, and now I'm going to take the derivative of the y portion, the y factor, to y. It isn't an x or a t, so we pick up this dy dt. And now the rest of it's pretty straightforward. Derivative of 3x is 3, dx dt. The derivative of y squared is 2y. Of course, it's minus still. dy dt, and the derivative of 10 is 0 d10 d. No, there's no such thing as d10 dt. It is 0. Um, and now, wow, we've got a bunch. You could solve this for dy dt. You might be asked to find dy dt, but I have a value for x and y. I have a dx dt. I'm going to throw some numbers in here. I don't know if
Agree. I do
I
it
don't
this
remember
way.
how Virge did it. Okay,
I'm never going to do extra algebra. Well, for the verify, you have to do it because you're not given any values. But
right.
here, you're trying to find a numeric answer. I put
Yeah,
in
if you were
numbers
asked
to
for dy
see.
dt in terms of x and y, then you would have to do it the other way. But um, y is -2, 3 is just 3, but dx dt is that -3/7, and y is -2. And there is a lot going on here. Um, I'm going to clean up a little bit. -2 squared sounds like
4.
4,
Mhm.
and 3 over here. So that's going to be 7 times -3/7. This is not the way most of you would do it, but I'm running out of space. So, and I forgot my equals 0. All right. 2 times 2 times -4.
Mhm.
That's going to be -8. Here I've got a +4. So -4 dy dt if I group my like terms.
Can I just go back to that 7 times -3/7?
Yeah.
Are you like combining your -3/7 there?
I'm treating -3/7 like it's a variable. So I have
Yes, I love that.
like a 3q and a
Uh-huh.
4q, and so I
Yeah.
end up with 7 of them.
Yeah, yeah,
Yeah, and
yeah.
like I said, I I don't expect everyone watching to do that way, but it worked out really nice in this case because now my sevens go, and I add that 3 to the other side, and then my final answer for dy dt is -3/4.
That's what I
And
got.
yeah, that was a really slick algebra trick because I saw E coming, and I just decided I needed to kind of fast forward. All right. So that's our method one. And take a screenshot of that or something because it's about to go away. It was -3/4 though. Remember that part, right?
Yep.
And then now we're going to come in for method two. And for method two, I'm going to take advantage. Sorry, I have an ant crawling on my desk. It's distracting. So, and now it's the Pink Panther. The dance.
Dun-dun, 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 dun-dun,
Right.
dun-dun, dun-dun,
So
dun-dun.
the one dy dt, right? That's what we're going for. Up here, we had dy dx, and that dy dx looks a lot like dy dt, especially if I multiply it by dx dt. This is one of the forms of chain rule.
Mm-hmm.
And if I know dy dx and I know dx dt, I can multiply those because if I know how y is changing to x and how x is changing with respect to t, then the product of those will tell me how y is changing with respect to t. Um, and again, this is not something everyone spots. Virge said she would do it the other way all day. But what's nice about this is when I'm trying to find dy dt, and again, we'll use that evaluator such that bar that 2 -2, then that's going to be dy dx at 2 -2 times -3/7, because that was that dx dt that I can substitute in. And Virge, I believe you found dy dx at 2 -2.
Right. That's why method 2 is good in this case because you already did the work to figure out that. And so we got 7/4 back in part B. But if I
Was
were
that B or
starting from,
C?
it was part B when we did the
Okay.
tangent line. But if I were starting from scratch, I would not do this way because,
Yeah, absolutely.
yeah,
Well, yep, I don't know. If you didn't have dx given, yeah, I definitely wouldn't. If I had dx given, even if I hadn't found it, it's nice to be able to just plug into a -2 into that.
true, true. We were given dy dx. I forgot about
Yeah.
that. Yeah.
Even if you weren't able to do part A and the show that, if you had totally dropped the show that ball, that's okay. On this part, you could plug 2 -2 into that and claim it's 7/4 and
Love
keep
that.
working.
Yeah, I love that.
And in
It's
fact, that
true.
was true of B and C as well,
Hmm.
right? You're not out if you couldn't show it because they handed it to you. So don't quit, right? That's important.
Yeah.
Um, and we have seen this on the AP test, which is why I wanted to demonstrate this method. It's cool if you think of it. And it shows up in BC with parametrics too and things like that. Okay, part E. A different particle moves along the curve V, defined by the square root of y plus the natural log of x over 2 equals 5. At the instant when the particle's at the point 225 now, so not 2, negative 2, in a whole different curve, the x dt is negative 4. Find dy dt at that instant and show the work that leads to your answer. Um, so this is a case where I can't use the method we used
That's right.
in part D for method 2.
That.
And Virg, I just noticed you called this curve V
Hmm.
and the other curve was M.
Hmm.
That's weird. Those
It's
letters seem
yeah, like it's
they
kind of
seem
like
kind of familiar.
if you're friends with a fiction author, you might end up in their book. Well,
Right. This
Mark,
is.
Verge, MV, sometimes you just can't
I
think of
wondered if you
anything
did vertical.
original.
Like, do you find yourself having a bias to vertical because it has that same first
Ooh,
syllable, or
not
it's
necessarily.
okay? All right. Anyway, back to our problem. I'm going to immediately rewrite that square root of y as y to the 1/2
Ooh, well, why
because
don't you rewrite natural log of x over 2 is natural log of x minus natural log of 2?
oh, that's a nice touch.
Thank you.
Of course, that only works if x is positive, but it is.
Yeah.
If x were negative, you are not allowed to do that because that natural log of a negative argument would be very bad.
Yep.
Um, but that's okay because over 2, it would still be negative and would have been bad. So we haven't left our domain.
Mm-mm.
All right. Um, and so I'm going to take my derivatives with respect to t.
Mm-hmm.
So 1/2 y to 1/2 minus 1. I always do just top minus bottom.
Mm-hmm.
1 minus 2 is negative 1/2. Negative 1 over 2. Um, but 1/2 minus 1. And then we get derivative of log.
Slow
Bird, remind me.
down, slow down. You forgot your dy
Ah,
dt.
what is this? I even wrote it down.
That's why I'm here.
Uh, I would have caught it when I said, "Oh, they want me to find UIDT, and I don't
Right,
have one."
right.
That's, all right. Log of x. What's the derivative of log of
1 over x.
x? And the derivative of log of 2 then is 0
0.
because it's a constant. 2
Yep,
is not a variable.
yep.
Um, if you had left it the other way, let's just talk about that. It'd be 1 over x over 2
Mm-hmm.
dx dt, which is 2 over x.
No, no,
Nope.
no, because you got to do a chain rule then. Yep,
And then those go. Get this.
yep,
And we end up with 1 over x, which is the same. That was
right.
the point I was trying to make.
Yep. That's why those properties of logs from pre-calculus are so super useful in calculus for rewriting. I think so anyway.
Oh, yes. No, they make it much easier.
Yeah.
All right. And while Virge was saying that, I just rewrote my 1/2 exponent as a square root. And because it's negative, I had to join that 2 in the denominator just because I know I'm about to plug in some numbers. And I thought it'd be
Mm-hmm.
easier to do it with that, with having it a radical. And so now we're going to do this 225. It's my x and my y. And I know that dx dt is negative 4. None of that has to be written, but I think it's sometimes nice to just kind of organize yourself. And dy dt is the one I'm trying to find. That's when I would have caught that mistake.
Yep.
And then dx dt is negative 4. So square root of 5, or square root of 25 is 5. Gave it
Mm-hmm.
away. 1/10 is dy dt. Half of negative 4 is negative 2. Silly hand. Okay. And then we will add the 2. And of course, you could do this in one step if you felt comfortable. Multiply by 10, and dy dt is 20 at that point,
Let me check my
225.
answer. That's what I got.
Yay. And
Yay!
I didn't put the such that bar here, which would make it formally more correct. But I think as soon as you see the numbers being plugged in here, and especially with
Yeah.
this
Totally
evidence,
fine.
yeah,
Totally fine.
I'm
Yeah.
not claiming it's always 20. All
Mm-hmm.
right. So that brings us to the end yet again.
Yes. And great job sticking with us. All of these skills are so important for success on your AP Calculus exam. So join us next time when we're hoping to
Bye.
do a tabular. Bye.
Yay. Bye bye.